In this video, we'll take a look at long division and then also a shortcut to long division with polynomials. So just a reminder, when you learned arithmetic, when you learned long division, you divided numbers, something like divide 2,357 by 12. So the division algorithm, you took the 2,357 divided by 12, and you take a look and you say, okay, 12 goes into 23 how many times? In this case, 12 goes into 23 only once. So we would take 1 times 12, which is 12, and then subtract 23 minus 12, which is 11. Then we would carry down the next number, 5. Then 12 times what goes into 115 without being over 115? Let's see, 12 times 10 is 120. That's too big, so 12 times 9. 9 times 12 is 108. Subtract. We get 115 minus 108, left with 7. Carry down the 7. 12 goes into 77. Let's see, 6 times 12 is 72. 6 times 12 is 72. Subtract, and we would be left with a 5. So if we wanted to keep going, we could put a decimal place and keep going, but we're going to stop right there and say that we have a remainder of 5. So we would usually write this as 2357 divided by 12 is equal to 196, and that remainder of 5 is actually 5 over what we divided by, 5/12. Or you could change it to a decimal. So the division algorithm, just to remind you, states that given a polynomial dividend f of x, in this example we had a numeric dividend, and a non-zero polynomial divisor d of x, where the degree of d of x is less than or equal to the degree of f of x, there exists a unique polynomials q and r of x such that your function can be written as the divisor times the quotient plus the remainder. Qx is the quotient, r of x is the remainder. The remainder is either equal to 0 if it goes in evenly, or has a degree strictly less than the degree of the divisor. If the remainder is 0, then your divisor divides evenly into f of x. And that means that d, q are factors of f. So in the case above, it didn't go in evenly, so that means that 12 is not a factor of 2,357. But if it did go in evenly with a remainder of 0, then it would be a factor. So let's take the same principle and use it to divide a polynomial. So we're going to take the polynomial negative 10x to the third minus 30x squared plus 5x plus 24 and divide it by 5x plus 5. So we can write it similar to the way we did this with numbers. Put 5x plus 5 on the outside, negative 10x cubed minus 30x squared. If you have a cubic polynomial, make sure you have all of the degrees listed. So this is x cubed, x squared, x, and then a constant. There isn't any term missing. If there was, you'd put a 0 in to hold the space. Okay, plus 5x plus 24. All of the terms are there. So now we take a look at just the 5x and the negative 10x cubed and go 5x times what gives us negative 10x cubed. So 5 goes into 10x times negative 2x squared. Negative 2x squared times 5x is negative 10x cubed. Then we take the negative 2x cubed, multiply it by our divisor, and write it underneath. We get negative 10x cubed. Negative 2x cubed times 5 is negative 10. Oh, that's an x squared. Negative 10x squared. Now, just like we did in long division with numbers, subtract. 10x cubed minus a negative 10x cubed cancel each other out. Negative 30x squared minus a negative 10x, that turns that into a plus, gives us a negative 20x squared. Then carry down the next term, plus 5x. Now we take a look at the first term. 5x times what gives us negative 20x squared. So that's going to be times negative 4x. Then we take negative 4x and multiply it by 5x plus 5. We end up with negative 4x times 5x is a negative 20x squared. Negative 4x times 5 is minus 20x. And we do the same thing we did up above. We're going to end up subtracting, so I'm going to change the signs and add. Negative 20 minus a negative 20x squared cancel each other out. 5x minus a negative is plus 20x, which gives us 25x. And we keep going until we run out of terms in the polynomial. So last we get 5x times what equals 25x. 5x times 5, so plus 5. Then we take the 5 times 5x plus 5. And we end up with 25x plus 25. Subtract. These cancel. 24 minus 25 is a negative 1, so I have a remainder of negative 1. So I want to write this. It says divide the following. Give your answer in the form quotient plus the remainder over the divisor. So our answer is negative 2x squared minus 4x plus 5 plus our remainder, which was negative 1, over the divisor, 5x plus 5. So that's long division with polynomials. So what we want to do is we want to be able to, so that process will work on any polynomial. The polynomials we're going to work with to graph are going to have divisors in the form x minus k, just a single x plus or minus some value. So we're going to use something called synthetic division, which is a faster version of what we just did. In the synthetic division, we use only the coefficients. So let me show you the shortcut. On the left-hand side, we have divide 2x to the third minus 3x squared plus 4x plus 5 by x plus 2 using the long division algorithm. So this is what it looks like with long division. It's very similar to the problem that we just did. What synthetic division does is it uses the numerical coefficients only. Again, make sure if you start with 2x cubed that you have an x squared term, an x term, and a constant. If one of those is missing, you put a 0 in to hold place. So we use the coefficients only. We're going to take 2, negative 3, 4, and 5, and instead of the division bar above, write it below and leave a little bit of space. We're going to divide by x plus 2. We're going to put on the outside the opposite of plus 2. We're going to put a negative 2 on the outside. That way, when you do long division, you subtract. If we put the negative up front, then we're going to add. So here's the process. You take the first, once you get it set up, you take the first value 2, carry it down. Then take 2 times negative 2, which is negative 4, and put it underneath the next space. Add these together. Negative 3 plus negative 4 is negative 7. Take negative 7 times negative 2, you get positive 14. Add these together, we end up with 18. 18 times negative 2 is negative 36. Add 5 plus negative 36, and we get negative 31. So that's the process. So if you memorize that algorithm, then what's along the bottom is our answer. So this 2, if we're taking 2x cubed divided by x, it's going to be 1 power smaller. So this 2 is going to be the numerical coefficient of x squared minus 7x plus 18, and the last number is the remainder. So we have a remainder of negative 31. So if you see how this is related to long division, The -7 here corresponds to this -7. The 14, let's see, 18 corresponds to this 18. The -31 corresponds. So it takes out all of the extra steps and does a quick process so that you can divide quickly. So let's try one. We want to divide, this will look like your homework. Divide 4x to the fourth plus 4x cubed plus x squared minus 5 by x plus 5. We've got to put our values in the answer. So we have 4x to the fourth, so use numerical coefficients only. 4x cubed. X squared has a 1 in front. There's not an x term, so we have to put a 0 to hold the 0x, and then minus 5. And on the outside, we're dividing by x plus 5, so put the opposite, -5, on the outside. Now that's the setup. To carry out long synthetic, carry down the 4. Then take 4 times -5, which is -20. Add these together, we get -16. -16 times -5, I think is positive 80. Let me get my calculator. Yep, that's positive 80. One plus 80 is 81. 81 times -5 is a -405. Oh, we're getting a huge number. Let me just double check. 4410 -5. And then -5 goes out here. Yep, 4 times -5 is -20. -16, positive. Yep. So 0 plus -405 is -405. Multiply -405 times -5. We end up with 2025. Add that to 5. -5 plus that would be 2020. So now that we've got the synthetic division done, how do we put our answer? And it tells us up above how we give our answer. We get the quotient. Since we started with 4x to the fourth, our answer is going to start with x to the third, 4x to the third, minus 16x squared, plus 81x, minus 405, with a remainder of 2020, but they want us to take this and add the remainder over the divisor, which is x plus 5. All right, so in the next section, we're going to take a look at using synthetic division to help us solve polynomials.